Alrighty, it is Thursday class, and you're watching. Hopefully, I want to make sure all you guys watch, and so it should have like 19 views on, actually 24, but some of you might siblings could share a view. So, but let me go ahead and get to the white screen here, and this is the class for April 4th. I'm recording it on the Saturday prior, so we've not even had Tuesday class when I'm recording this, so I have no idea what's going to happen on Tuesday, but we'll do lessons 99 and 100 on Tuesday. And so by the time you're watching this, those should have already been done. And then we'll do lessons 101 and 102 here today. And these lessons are actually relatively easy. So that's good on a class where it's not as interactive, well, not interactive at all, because you can't stop me and ask me a question. So I don't do this often like this, but anywho, let me go to the white screen here. And are y'all behaving yourselves? Sure hope you are. My wife's here. She nodded her head. I had put the camera on her, but she'd be embarrassed. She doesn't want me to do that. So, all right, let's see if I can make this work. All right, that does work. All right, let me get a little bit bigger of a stroke there. All right, so let me just quickly review something that we learned a little bit on Tuesday, I'm assuming. And the perfect squares, you learned about square roots and how square roots are connected to exponents. So I'll just put an X in this to show you. And so this here is kind of review here. This little division bar looking symbol is called a radical sign, and it represents a root. So I'll sometimes call this a radical. It's even called a root at times. And it is the inverse of this exponent, which is a square. And so, and I told you before that it's muy importante for you to memorize all of the perfect squares, at least to 15, 225. So let me go over those again and then show you how all this is connected. And then if it's not a perfect square, what that means. So far, all that you've done in class is the perfect squares. And but if it's not a perfect square, there's a couple different ways to do that. And so we'll start with 1. And so 1 times 1 is 1. Let me just erase all this and start over here. And let's go. 1 times 1 equals 1. And so the square root of 1 is equal to 1. Okay? And let's go 1 squared. So let's go 2 squared. So 2 is the base. The 2 here is the exponent, this little postscripted 2. And so that means this right here, doesn't it look like a, tell me if what do you think that looks like? Somebody chime in, tell me what you think that looks like. That looks like an absolute value, doesn't it? It's just 1 times 1, but those look like absolute value bars. I looked at that confused me. So 2 squared, 2 times 2. 2 times 2 is 4. So the square root of 4 is going to be 2. You see all this is connected. 2 squared is 4. The square root of 4 is 2. Let's go to all the way through here. 3 squared is 3 times 3, 9. So 1, 4, 9 are all perfect squares. Those perfect squares can go into a square root bar, and they come out perfectly evenly because, and look at here, 1, 2, 3, right? And so let's just keep on going down the road here. 4 squared is 4 times 4, 16. So the square root of 16 equals 4. So this root sign means something times itself is equal to. And as I told you before, you're going to get to math where it's going to go plus or minus also, because a negative times a negative is also a positive, if that makes sense. So, but we'll just put the positive right now. I just showed you that right there. So this is kind of review from Tuesday. 5 squared. 5 times 5 is 25. So the square root of 25. So inside this radical sign means something times itself. Something times itself equals 25. Is it perfect square? Meaning, is there a whole number without a decimal or a fraction that equals 25? Yes, there is. 5 times 5. And by the way, they'll do in math, and even in Algebra 1, the class I'm going to teach in about 10 minutes, they kind of bait you sometimes with these perfect squares. That's why it's important for you to memorize them, because when you're factoring these later on in math, when they bait you with one of these and you see it, it'll save you a lot of time. You just got to trust me on that one. You say, I have no idea what you're talking about, Mr. Soto. Well, just trust me. Memorize these perfect squares, And so far, our perfect squares are 1, 4, 9, 16, 25. And we could go on 49. Of course, you could just fill all that in there. Then you have 8, 64. Then you have 9, 81. So again, 9 squared means 9 times 9, which is 81. And the square root, or the, again, squared root, a number times itself equals this. Well, since 9 times 9 is 81, this is a perfect square. 10 squared, 10 times 10, 100. Square root of 100 is 10. So that is, then you got, let me just go through quickly and give you the ones all the way to 15. So we got 121, 11, 144, 12, no hash marks for penmanship, 169, 13, 196, 14, 225, 15. So all those numbers there inside those radicals, are those all the perfect squares? Now, let me just delete this real quick. If you take any number, like let's say you have 49 equals 7, and you have 64, which is equal to 8. If you have any number in between 49 and 64, you're going to have a square root that's not a perfect square. So let's just randomly pick a number. Let's say 54. Okay. And so 54 is not a perfect square. There's two ways to do this. One of two ways is to, you can take your handy dandy calculator and you can go 54. So you do like that. You push 54, boom, boom, 54. You push that little button right there. That's the square root. And when I press equals, you're going to see a number that goes on forever. It's irrational. And notice what it looks like there. It's 7.3484692283. When I say irrational, that means it goes on forever. You see how these perfectly terminate at 7 and 8? This is 7.34. 7.3484, and it goes on all the way to about the 10 millionth spot. They might tell you to do something like to the 10th place, 100th place, 1000th place, and you just rounded that number. Like let's say they said the 100th place, you would say 7.35, because this 1000th place would round the 4 to a 5. So you could erase this 4 and all this stuff here, and you could just go 7.35. This is in the 100th place. Remember, you can't put equals, though. You have to put approximate, because this little squiggly line equal sign is telling you that this is an approximate number. So here, if you notice again, this 7 is perfect. This 8 is perfect, but in between is 7.35. Now, if you did this, if I put 7.35 times 7.35, you're going to get very close to 7.35 times 7.35. Okay? You're going to get very close to 54. But since we rounded, it's not going to be exactly 54. Let me show you. It's 54.0225. Okay? So the rounding rule makes that where, and again, the further you go out on that irrational number, the closer you're going to get to the original value. But you have to put this approximate here because you're saying I rounded up or I rounded down, depending on how, rounding rules. There's one other way to do this, and this is do the approximate way, and then this is all kind of review. But 9 times 5, is that right? 9 times 6 is 9 times 5, 9 times 6. Why am I blinking on these things right here? Sorry about this. Yeah, 9 times 6. That's right. Sorry about that. Brain freeze. So I just used a factor tree here. My kids think I'm going C now. Like I can't remember anything anymore. And so, do my students think that too? So watch what I've done here. I went prime factorization. 9 times 6 is 54. And 3 times 3 times 3 times 2. 3 times 3 times 3 times 2. Anytime it appears twice, it can come out once. So these two threes come out one time. You have a 3 and 2 left over. So this 54 can be expressed two ways. It can be reduced to 3 radical 6 or irrational number 7.35 at the 100th place rounding. All right, so that's kind of all review. And let's do this. Let's go to lesson 101. This is going to be very simple. Okay, so I spent a little bit more time reviewing because this is going to take us probably 5 to 10 minutes at the most to do 101 and 5 to 10 minutes at the most. But let me just say this, as easy as this is, it's very, very crucial that you understand and learn what I'm teaching you because this is going to resurface in math a whole lot. So we're going to say 4 to the we already did these problems where you have 4 with an exponent of 4 over 4 with the exponent of 3. Excuse me. And so again, you could just do the -3 here. Again, bases are the same. Thank you, Bamfer. Say hello to everybody. You want to come over and say hi? Now I've got me a water lime sparkling water. I got a flutter in my throat because I was mowing the lawn and I got all those lawn clippings right in my throat. It was 4 to the 4th power over 4 to the 3rd power. Remember, if you have the same bases, you can, and the numerator exponent is bit greater than the denominator exponent, you can just subtract the exponents. Okay, and that's just rules of exponents. And I showed you why before. I think with if you factor that out, 4, 4, 4, 4, 4, 4, 4 on the bottom, then they cancel out. So now we have 4 to the 1. Okay, now every number you've ever seen any time in your entire life always has had an exponent here of 1 understood if it's a 1. So 4 by itself one time is just 4. So anytime you have an exponent to the power of 1, it's just itself. So for example, 4 squared is 4 times 4, which is 16. 4 to the 3rd power is 4 times 4 times 4, which I believe is 64. Then 4 to the 4th power is 16 times 16, which is 225 plus 32. Let me do 225 plus, no, 225 plus 16. Nope. Oh, da, 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 da. Let me just throw it this way. Yeah, 256. I knew that. Yeah, that's silly of me. Silly of me twice now. Give me a hash mark for that one.
Late for us.
It's late. 256, not 254. There we go. Which you should know that anyways, because the doubling rule, like 1 to 2, 2 to 4, 4 to 8, 8 to 16, 16 to 32, 32 to 64, 64 to 128, 128 to 256, 256, to 512, 512 to 1024. That's the old adage, if you give me a penny and double it, and the 256 falls right in that realm. It's the same as 2 to the 8th power, right? And so 2 to the 8th power is also 256, right? There you go. So, all right. So back to what we're talking about. So this is number 1. You just say 4 to the 1 power is 4. Again, 4 itself one time. If there's no exponent, it's understood as 1, and then you can leave it there as well as just 4 if you want to. So you could go 4 to the 4th power over 4 to the 3rd power, 4 minus 3, 4 to the 1 power is just equal to 4. And so that would be letter B, would be the answer there. All right, so now we have x to the 6 over x to the 5, same thing. Oops, that's a big exponent. And so 6 minus 5, x to the 1 would just be equal to x. All right, so that would be letter E for number 2. All right, why don't you do not 3, 4, and 5? And it's so easy once you see it, right? It's just whatever that value is, because 9 to the 10th power over 9 to the 9th. I'll let you do 3, 4, and 5, and then should be relatively easy. Okay. What I tell you, once we get this down, and but this is something you do need to know and recognize because there'll be times it's like, let me just give you a reminder of something. Let's just take an X like this. And by the, so yeah, number three is just nine, letter C. Number four is just X, letter A. And number five is just B, two. And so again, but if you have a variable like this, X, right? There's an understood one here, coefficient. There's also an understood one here, exponent. Now again, X times X. Let me not do it times, it looks like that. X plus X, okay? X times X, you have an understood one here, understood one here. Remember when you multiply bases that are the same, you just add the exponents. It's not one times one. You see, even though this is times here, this is one plus one because that's the exponent rule. So it's X squared here. And this X plus X, you have the understood one there, the understood one there. One plus one is two, so 2X. So X times X is X squared. X plus X is 2X. All right. And all right, so that's how you do that. And that's what we're seeing there on 6, 7, and 8. So you have, so that first, in the first number 1 through 5, all you're doing is subtracting the exponent on the denominator from the exponent on the numerator. If your base number is just 4, like it is on 1 or any to the 1 power, it's just that. So 4, just 4. If it's X, it's just X. That's really easy, cheesy, lemon squeezy. Let's look at number 6 now. Again, X to the third times X. Okay, so you have an understood 1 here. You're multiplying bases that are the same. When you multiply terms with bases that are exactly the same, all you do is add the exponents. And I could show you why in a second, and I will. So 3 plus 1 is 4. So it's X to the fourth power. Okay? And again, X to the third could be expressed like this, right? And X to the 1 could be expressed like this. And remember I told you before with all these ones right here? 1, 2, 3, 4, X to the fourth power. There it is in just illustration form. You don't have to do all this here. I'm just showing you that's why it is that way. So your answer is letter E, X to the fourth power. And then for number 7, again, X times X to the fifth power. And so again, you have, this is a 1. You're multiplying, the bases are the same. You simply add the exponents. 1 plus 5 is 6, X to the sixth power. Your answer is letter D. All right. And then number 8 is X to the eighth, X to the 1. Bases are the same. Add the exponents, X to the ninth. All right. So that's not too terribly difficult. And so that is lesson number 101. I was going to say something also that I thought was important for you to remember. I can't remember what it is now, though. If it comes back to me, I'll let you know. If not, I'll tell you. Oh, by the way, after today's class, we have a 2-week break of no NHA. And so we'll see you again on April. Wait for it. Wait for it. April 22nd. So April 4th is the day you're watching this, and April 22nd is when we get to see each other again. So have a good, safe time doing what you're doing. Now, let's look at number 1 on lesson 102. And this, again, is something you really, 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 really need to know. But once you learn it, it's on the easier side of things. So we have 5 squared over 5 squared. And you're going to just subtract again 5, 2 minus 2. So you have 5 to the 0 power. Now, before you start thinking, well, 5 to the 0 power has to be 0, that is actually not accurate. And this is where, and I'll show you why in 1 second. Any number, doesn't matter what it is, if it's one digit like 5, if it's 1,673,541, 541, then it's to the 0 power. The answer is always the same. The answer is always 1. So 5 to the 0 power does not equal 0. 5 to the 0 power equals 1. Let me show you. 5 squared over 5 squared. You can do it like this and watch. These just cancel out, but there's an understood 1 in front of everything. So the 1 over 1 is just 1. Anytime, like, let's say, for example, you had this fraction, 4 over 20, okay? You have to leave this 4 divided by 4 as a 1, right? And 20 divided by 4 as a 5. You always have to leave that 1 up there because it'll change the value. Similarly to that, you have to have that 1 from that to the 0 power. So anything to the 0 power does not equal 0. Anything to the 0 power is equal to 1. So the answer to number 1 is going to be letter D because it's equal to 1. So back to 5 squared over, and it might be even easier to see with an exponent because, or with a variable, because and if we get to one of those, yeah, the next one will be that way. And I think you'll even see it a little more clearly. Let's square both of these out, right? 25 over 25. Okay, well, 25 over 25 reduces to 1 over 1, and 1 over 1 is equal to 1. So as you can see, 5 squared, 2 minus 2, 5 to the 0. Well, it's still got to equal to 1 because equals means the same, right? So 25 over 25, 1 over 1, 1 over 1 is equal to 1, not 0. And so that's equals to 1. 5, so 5 to the 0 power, either way you do it, you're going to just get 1, okay? And so anytime you have a 0 power, the answer is equal to 1. Doesn't matter what the number is, doesn't matter what the value is. Even if it's looks like this with an exponent. You have x to the 12th over x to the 12th. So now you have x to the 0, because 12 minus 12 is 0. And you might just want to say 0x, that wouldn't be correct. 0, that wouldn't be correct. 1, that would be correct. That's the correct answer. So your answer there is letter D, number 1. So that's always the case. 3, 4, and 5. The answer will just be 1 every time. That's easy, isn't it? 1, 1, 1. You don't have to do anything. All you have to do is look for the 1. For 1, 2, 3, 4, and 5, look for the 1. Well, you got to make sure, first of all, that it is the same exact over the top and bottom. The 12 and the 12, for example, here, and the 8 and the 8 in number 4, the 5 and the 5 exponent in number 3. Also have to make sure the bases are the same, but in all these examples, the bases are the same, the exponents are the same, and so the answer is equal to 1. Now, here's something to think about. You can give me your answer when you get back on the 22nd. 0 to the 0 power is a conundrum in math. And so if you can figure that one out, you'll be very smart, because anything to the 0 power is 1, but 0, so it's kind of like having 0 as a denominator. You can never have 0 as a denominator because it messes everything up if you ever have a 0 as a denominator. So a lot of debate on 0 to the 0 power. I'll let you do your research and due diligence. Now, so let's go ahead and go to the next little part here, and we'll be done here in about just 3 or 4 minutes. So maybe a little bit shorter of classes, which is okay. So now what you're thinking to yourself is here you have x to the 4th power times x to the 0 power. So you're thinking to yourself, well, 4 times 0, put x through there so you don't give me a hash mark. 4 times 0 is 0. So x to this must be 1. But it's not, because remember our rules. When the bases are the same, you add the exponents. It's not 4 times 0, it's 4 plus 0. So let's go ahead and rewrite these, erase these ones that I x'd out. So you have x to the 4th power, x to the 0. So in this particular one, you want to simplify first. I guess if you made this 1, either way, you're going to get the same answers. Watch. 4 plus 0 is 4, so it's x to the 4th power. Or if you went x to the 4th times x to the 0, which is just 1, well, anything times 1 is itself. So either way, you're going to get x to the fourth power. They probably want you to do 4 plus 0 just because you might have some later on in math that you want to, that there's a multiple chain of them and you don't want to confuse yourself. So I would say the 4 plus 0 is x to the fourth power is the right way to simplify. I shouldn't say the right way, but probably the best way moving forward in math. But in this particular instance, you can't just make that one in itself. Seven's the same way. So you have x to the 0 times x to the 11th. Well, the bases are the same. You add the exponents. 0 plus 11 equals 11. So x to the 11 is going to be your final answer, and that is letter C. So you don't multiply these, you add them. When you multiply bases that have the same bases that have exponents, you add the exponents. And I think I showed you this before. I think this is the thing I was going to tell you before. But like when you do square foot, like you did in the 5th grade, and you have 10 times, let's say that's 4, and this is the area of something, and you have 10 feet times 4 feet. Now watch this. This is going to be really cool. You're gonna appreciate this. 10 times 4 is 40. Look at this. Feet to the 1 power times feet to the 1 power. 1 plus 1 is 2. So now I have 40 feet squared, or 40 square feet. That's where you get that exponent of 2 that you learned about when you were in the 5th grade. It's always been there. You didn't know why it was there. Now you see it mathematically. This is the reason why, because you're saying feet to the 1 power times feet to the 1 power. The bases of feet are the same. 1 plus 1 is 2. That's why length times width times height gets us, inches cubed, because this is 40 inches times 30 inches times 10 inches, inches times inches times inches, 1 plus 1 plus 1, 3. Not 1 times 1 times 1. I realize these is multiplication here, and you multiply the whole numbers, but the exponents you add, that's your exponent 1, that's your exponent 1, that's where you get the 2. Length, width, height, that's where you get the, even like the area of a triangle, base times the height, right? Area equals base times the height. We have inches times inches, and it's squared inches. All right. So that's free for you. Number 7, we did that already. Number 8, it's x squared times x to the 0. 2 plus 0 is just 2. So x squared is your final answer. All right. Well, that's going to call it 13 weeks straight since we gathered. And I think it's the longest stint we've ever had in NHA history, because spring break fell so late this year. And a lot of times it's 9 or 10 weeks, and then we go out for 2 weeks and come back for 3 or 4 weeks. But this time it's 2 weeks off, then 2 weeks back, and we's done for this year of NHA. Let me put the whiteboard off so we can do peace out, and we will call that a class time. And we'll see you on April 22nd. Have a very safe and productive spring break.